Hello interwebs, welcome to Let's Fix Computers. I just watched Jay's 2 cents. Jay's 2 cents is his most recent video, where he was fixing his Titan V, I think it was, RTX Titan V. Big expensive graphics card. He had previously used it in an overclocking competition, during which he had applied liquid metal across the current sensing resistor in order to trick the card into thinking it was using less power than it actually was, thus enabling him to use even more power and reach higher clock speeds. And he needed to remove that modification to the card, and unfortunately while he was doing so, he accidentally broke off the current sense resistor. So firstly, this is not a Titan V. I've never seen one of those. This is a GTX 960, and the eagle-eyed ones among you might recognize it as that one card that I did the really bodgy repair on. We're actually going to fix this thing properly at some point. Not today, I'm still waiting on parts. I'm waiting for some new MOSFETs to show up from China. They're taking ages. Anyway, I've removed the current sense resistor. So what we've done here is I'm reproducing the fault that Jay had where he accidentally broke off the current sense resistor. And so let's pretend that you're not familiar with soldering, and on your graphics card or some other component, maybe on your laptop or something like that, you've just dinked a component and it's popped off the board and you're like, oh, I'm screwed, you know, nightmare situation. So this is the situation that Jay was in. Basically, he accidentally dinked a component off his $2,500 graphics card and was like, balls, I've just broken this graphics card. So he said during his video, he made note that he couldn't really find many research information on how to deal with this. And there's plenty on YouTube, to be honest, but perhaps he just didn't know, because obviously in YouTube it's such a sea of information that it's hard to find something that you consider trustworthy. At the very least, this video is not about me flexing on Jay because I can solder. Obviously I can't flex on Jay, he's leagues above me. However, what I wanted to do is I do know how to solder, so I thought I'd demonstrate how I would have responded to this situation. Now, obviously, as he discovered in the video where he broke the graphics card, his comment section then immediately got swarmed by all of the armchair technicians who go, oh, you need to send it to such and such. A lot of people said send it to Lewis Rossman. Great idea, by the way, you know, he'd be able to sort it out. But a lot of people said, sort of, oh, you need to do this, that, and the other. And, oh, it's really easy, you just need to do this. And, oh, you need to buy all this expensive equipment. So the thing is, expensive soldering equipment is better. It does make the job much easier. However, it's not critical. And the other thing as well is that in the real world, people who are stuck in this nightmare situation, they're not going to rush out and buy $700 worth of equipment to fix it, especially when you could just pay someone else to repair it at that cost. So what Jay had done, he went out to his nearest hardware store and bought a cheap-ass soldering iron. And as soon as he took that soldering iron out and put it on the desk, I was like, oh, what is that you've bought? However, he was like, I did what any normal person would do. I went to Lowe's, I bought a soldering iron and some solder. Also, screw that motorbike in particular for being obnoxiously loud. Anyway, he did what any normal person would do, and he just bought a soldering iron and he tried to solder it. Now, he did actually get it done, so kudos to him. Yes, it was a little bit sketchy to watch. However, hecking good job, because you had to go and you did it, and I'm a big believer in that. So, in this video, I've got a really sketchy soldering iron, and I'm going to try and fix it using a sketchy soldering iron. So, firstly, let's take a look at the irons that I've got in front of me. I'm going to explain some differences between them. So, let's jump to that scene. Firstly, my normal weapon of choice is this. This is a TS100. These things are about, I don't know, $60 or $70 maybe. Might be a bit cheap than that, might be $50 these days. It's been around for quite a while, this soldering iron. By the time you've bought some accessories for it, I would be budgeting about $100, you know, £100 or so for it. And by a couple of accessories, I mean a couple of different tips and a power supply for it, because this guy typically doesn't come with a power supply and you've got to power it from a DC supply. Incidentally, a Toshiba laptop charger, a 65-watt Toshiba laptop charger, is perfectly fine to power one of these. It'll plug right into the back. The Toshiba charger will fit that connector, and it'll give it adequate power. It's not full power. This guy will run up to 24 volts, However, it will give it enough to be completely functional and get up to maximum temperature. So yeah, this is my normal weapon of choice. I have a knife edge tip on it. Let me give you a close-up shot so you can see what tip I have and why it's a good tip. So as you can see, the tip I have here is a wedge, and well, it's a knife edge basically. So it's not going to cut your hand open, but as you can see, it ends in 2 sharp points. And the important thing is there, because we've got this slope on the edge of it, the problem with very small tips is that you can't get the heat of the iron all the way down to the tip. Whereas on this one, because we've got these 2 slopes on the sides of it, we can. Now by comparison, let me grab a really fine point tip. Which iron? That's not it, is it? No. Ah, here it is. Here's a fine point tip for one of my other irons. This thing is rubbish because it ends in a very fine point tip, and you've got to get, like 350 to 400 degrees centigrade down to that very tip. And because there's no metal down there, there's not enough thermal mass to get the heat into the thing you need to solder. Which means this tip is actually incredibly difficult to use, which is why I never use it. And then a typical soldering iron will probably have just a fairly average tip like this on it. So this one, as you can see, again, it's a point tip, but if I compare it to that one I just showed you, where's it gone? I literally just threw it away in disgust. Nope, it's gone. I'll compare it to the TS100 so you've got a base of comparison. So as you can see, the TS100, because it's got that straight flat edge, there's a much more metal, and it gives me even greater precision at its very tip, but it also gives me that big flat space to apply heat. So that's why this knife edge tip is so good. And this is fine for hobbyist stuff. If you're like doing a soldering kit or something like that, this thing will be absolutely fine. However, when you start getting down to SMD work, this guy will be a bit of a hard job. So now here's the third option. So this is an Antex 12-watt soldering iron. I don't know why I bought this. It was before I knew anything about soldering. I bought it from Maplin's, which is our equivalent of a Radio Shack. But yeah, this thing's got quite a fine tip on it. But as you can see, look at the state of that. I think I've used this about twice and never ever cleaned it. So this is our worst case scenario soldering iron. Most people, anyone in the audience who knows anything about soldering will take one look at this soldering iron and go, what the hell is that? You do not have a hope in hell with that. Well, maybe they'll be right. We'll find out. Let's see if we can do it. So finally, there's one more thing I want to point out, and in the selection of good versus crap soldering irons, is these 2 soldering irons both have a thing in common that this one is different about. So on this soldering iron, this has an interchangeable tip on it. If I unscrew this bit here and remove the tip, that is the actual heating element there. That's the bit that heats up, and the tip is going on the end of it there. And then this collar sits across the top of the whole thing and just presses it against the heating element. Now there's not very good thermal contact between the tip and the heating element, and you lose an awful lot of heat just getting to the end of the soldering iron. So that's why these soldering irons are not very good. They work, but they're just, when you get to a professional level, these things are pretty bad. However, it's passable. Now by comparison, the TS100, if I just swap out to, I've got a wedge tip here for it. This is one of the replacement tips for the TS100. Now notice that we're replacing the entire section. So the whole thing is a single piece of metal with the heating element in the tip, and it gets its power from these terminals. So the power goes through, and the heating element is physically inside the tip where it'll all be bonded together. So all of that heat is going straight into the tip. And that's one of the reasons why this little TS100 is such a powerful soldering iron despite its diminutive size. Now, when you use really posh, expensive soldering irons like Hakos, and stuff like that, you'll get the same thing. The entire tip will be replaceable as a single unit like this. And that's one of the things that makes those soldering irons so much better. So now I've told you a thing or two about soldering irons. This is why people say, oh, you need this soldering iron. However, I'm guessing that you guys don't have a good soldering iron lying around. So we're going to try and use the crap ones. So I'm not going to use the TS100. That's easy mode. I'm going to try and do it with this piece of garbage. And if that doesn't work, I'll resort to this one. So this soldering iron is this one is temperature controlled. It's part of my WEP 2-in-1 station. And you can buy a soldering iron like this on eBay for, I don't know, 40 or 50 quid tops. So probably the equivalent in dollars. 40 or 50 bucks. And you will have a temperature controlled soldering iron with a replaceable tip like this. But again, the point of this video is that I'm assuming you're going to be in a desperate situation where, if you had money, you'd be getting it fixed by a professional anyway. So you're probably going to use just whatever you can get your hands on because you're desperate. So let's try this thing. This might be a waste of time, but let's find out. So the first thing I've got to do is plug it in and warm it up. These non-regulated soldering irons where you've just got a mains plug going straight into the soldering iron, no temperature control box or anything like that, they have no control of them and they tend to take a very long time to heat up. So I'm going to get it plugged in and I'm going to wait like a good 10 or 15 minutes for it to heat up. So let's plug it in. Right, that's plugged in. So while we wait for that, this is a soldering iron holder I've got. This came with my 2-in-1 kit. Your soldering iron may have come with some kind of rudimentary holder. It might have come with something similar to this. It might have come with just a folding bit of metal that sticks up and you just rest the iron on it, like that kind of thing. Those are not very good. But again, if in a pinch, it's fine. One thing I do recommend doing, most soldering irons will probably come with a sponge. This is just a kitchen wire wool scratchy. Go down to your local supermarket and buy a 2-pack of these for $1 or £1 or something like that. These are much better at cleaning tips than the sponges. So I recommend using one of these. And as I say, just buy one of these from the supermarket and literally just wire tie it to your holder. And now you've got something you can use to clean the tip properly. So I'm going to leave this to heat up. I'm going to put it in there just so it loosely fits. I'm going to put it in there. I'm going to leave it to heat up. And then the first thing I'm going to do is I'm going to try and salvage that tip. So yeah, while we wait for that, other things I've got a spool of solder here. This is the solder I use daily. It's quite a thick solder. For SMD work, you want thinner stuff than this, but this is just what I have. You want leaded solder with a flux core. That will make your life significantly easier. So again, if you have a choice of what kind of solder you're buying, get leaded with flux. If you've got like some grotty old stuff, like this is ancient, this is probably 40 years old, this solder, you can see where all the flux has bubbled up out of it. But really old solder like this is probably better than the newer stuff because it's got all of the glorious, not good for your health chemicals in it. So yeah, the other thing that people will often see me using, I've got some eBay flux here. It says it's Amtech. I doubt it's actually Amtech. However, this also makes life easier. But again, it makes it easier, but it's not critical. I will not be using this today because it's cheating. So I can feel the heat coming off that. That's warming up. I'm going to leave it for a bit longer. Let's see how this thing is doing. So the way we're going to check if we're up to temperature is we're going to try and melt some solder on it. So I'll just touch some solder to the tip. Yeah, there we go, that's working. So I'm going to put some solder on the tip of the iron and then I'm going to clean it using the wire wool. I'm just going to dig it around in there and just scrape it all off, basically. Okay, that's coming up quite nicely. Let's do that again. So this is known as tinning, where you're applying a fresh layer of tin onto the tip of the iron. And there's various people who drone on about taking good care of your soldering iron tips and stuff like that. And as long as you keep the tip reasonably clean, it's fine. I mean, you'll notice, like, I don't clean my iron every single time I put it away. You don't need to. It'll be fine. And plus, like, that TS100, new tips for that soldering iron are like $10 on AliExpress. If I kill a tip, who cares? I'll buy another one. Anyway, yeah, this is cleaned up quite nicely. It looks like just the last time I used it, I just put it away in disgust and didn't clean it up. I was like, to hell with this thing. So that tip is now cleaned up nicely. You can see we've got a nice tinned tip there, which is good. Because the solder, that will shrug off the solder because you don't want the solder to stick to the iron, you want it to stick to the subject. So, okay, that looks good. Okay, so with that out of the way, I've got my soldering iron all warmed up and we've cleaned it up. So let us now attempt to repair this. So we've got to put this back onto these pads here. Now, firstly, on this particular graphics card, this is quite an enclosed area. However, this plastic connector, we can easily remove that. When you've got a connector like this with some pins sticking up, the plastic bit, that'll slide right off. So if I just get a metal prying tool, metal spudger like this, and I'm just going to stick that under there and just ease that off. Just step it out. There we go. Take note of which way round it goes. Now we've moved that bit of plastic out the way, which means we're not going to melt it or anything like that. So firstly, it's not critical to know what the component is that you've broken off, but it's helpful to understand what you've got. The most common SMD components you're going to see, these are capacitors, and this thing here, this is the current sense resistor. Now what you'll notice is it has 4 pads, and what we've got here is we've got the power coming from this power connector is going through this resistor and then to the rest of the power system. The 2 smaller pads, these 2 here, will go back to the power management controller on this, the power controller chip. So this resistor will have a very low resistance. Quite likely it's like 0.5 of an ohm or 0.05 of an ohm. Very, very low resistance. And what will happen is the voltage going across this resistor will drop ever so slightly. And the more power that is going through the resistor, the more that voltage will go down. But it will only drop by a tiny, tiny amount, which is not enough to disrupt the thing that's being powered from it. However, that voltage drop is enough to be sensed, to be detected. So these 2 pins here, these are going back to the power management chip that will sense a tiny voltage drop across this resistor. And by sensing that voltage drop, it can calculate how much power the graphics card is using. So it can sense it can calculate the amps and the watts that are passing across this, and thus how many watts are being pulled through this connector. And that lets the graphics card know how much power is available to it. So the resistor itself only actually has 2 pads. These pads are joined at both ends. So you might ask yourself, well, why is there 4 pins then? Well, the answer to that is the closer your sense pads get to the resistor itself, the more accurate the measurement is. And so they don't want these to touch. They don't want these 2 terminals to be touching right until you get to the actual resistor. And it's quite common for current sensing resistors to actually have 4 pads on them as well. So you're getting right into the package of the resistor before your sense lines are actually touching the power lines. However, they do need to touch at some point. So on this resistor, it's only got 2 terminals on it, 1 at each end. So these pads will actually be joining at the resistor. So we don't need to worry about these joining together because they will do in that solder blob anyway. So that's the first thing. This is the first part where Jay went wrong. Well, he didn't go wrong because he fixed it, but that was something that he misinterpreted. Is he was concerned about these 2 touching each other, whereas in reality they'll be touching each other once you get to the resistor anyway. So that's not a big deal. So what we need to do now is put that on there. Now a lot of people will be like, oh, you need a hot air station, gonna hot air that on. It's like, we don't have that. We've got this epoxy 12-watt soldering iron. This is all we have to work with. So how do you solder SMD stuff with a soldering iron? The technique is quite simple. What you need to do is you need to try and remove as much solder from the pads as you can. These are already quite low, where this has been machine soldered, so there's not much to it. So I'll just touch up those pads and just make sure that they're nice and clean. Oof, yeah, that's not even going molten here. So what we're going to do firstly is we're going to solder this from one end and then the other. And so I'm going to get my solder and we're going to put a little pillow of leaded solder on one end. So I'm just going to hold the soldering iron against the pad and just put in a bit of solder and we'll just let that flow. There you go. So that's flowed onto the pad and we'll just do the other pad as well. Can I use that solder again? Not really. Let's put a bit more on. Just a little bit. This solder is too big. There we go. So now we've got 2 shiny pillows of solder on one side. Don't do the other side yet. We want the other side to be as flat as possible. And so now we'll get this guy in position. And now what I need to do is I need to reheat those solder blobs and let the components sit down on them. So let's heat those up. And just nudge this guy into place. And this is where I need to start fighting the iron, because the iron does not have enough thermal mass to properly heat everything up here. So I'm starting to have difficulty getting the solder to melt because I don't have enough heat. If I had a bigger soldering iron or a better soldering iron, I wouldn't have this problem right now. That's where the expensive stuff comes into play. So let's try and get those guys moving again. It's not going to happen. Once you've got the solder molten, you're laughing. But while it won't flow, it's difficult. So what I'll do is I'll put a bit more solder in there. And that's going to help me get more thermal mass into there to hold the heat for longer. So now we've got everything moving again. I'm going to nudge that into place. Nudge that along. And try and hold it down. Oh, it's gone sideways where the solder is not melting properly. This iron is horrifyingly bad. There, that'll do. Off. Right, now it's on. I'm going to go a little bit further and just try and straighten that up slightly. If anyone else was doing this, I would say quit while you're ahead. There we go. Right, and that's on one end. And I'll just quickly show you what that looks like. I'll clean the iron in my wire wool. Put that away. So as you can see, we're not sitting directly flat on the board, but that's very difficult to do with the equipment that we've actually got to hand. So all of that black schmutz, that's from the burnt flux and all the other slag. Don't worry about that, we'll clean that up in a moment. However, we've got a good solid connection. That is soldered on, that's not coming off. I can nudge that with my fingernail there, and that's not coming off. So that's all good. Now we need to get the other end. So now, I'll turn this around. Soldering iron out. And we're just going to feed some solder under the component there with the iron in place. And because there's no heat there, the soldered blob doesn't want to flow because the metal is cold. Let's try and get some more in there. There we go. Is it going? It's trying. I'm just holding the side of the iron under there. There we go. So notice how I'm using the edge of the iron and not the tip, because the actual tip is going to do bugger all. I can press that tip into that and nothing will happen. But if I hold the edge of the tip in there, we get far more heat transfer and it heats and starts flowing like that. Right, let's see if we can remove that solder blob. I'm going to turn it around. I'm just going to try and get rid of this guy. He's not doing anyone any harm, but I think I can get rid of it. There we go. And again. There we go. Clean the tip. Okay. And there is a rough as guts solder job. It's not pretty. However, that is electrically solid now, and it's not going to come off again. Again, flick that with your fingernail, not coming off. So what I'll do now, now we kind of want to clean this area up a bit. All of this noise is from other repairs I've been doing to this board. Now, to clean up soldering stuff, I would normally use isopropyl alcohol, which you can buy. Do I have the bottle? Yeah. You can buy this in bottles from Amazon. This is 99.9% proof stuff, so this is I don't want to say laboratory grade, but it's high grade stuff. It's decent. 99% or 99.5 is probably fine as well. When you get the lower grade stuff like 70 or 80%, that's known as rubbing alcohol. It's a poor man's isopropyl, basically. It's probably good enough to all intent and purpose. It's worth having this stuff lying around because it's really good for cleaning things. If you don't have any though, add a push, window and glass spray. This stuff evaporates very quickly, which means it's good for cleaning up electronics. So it's perfectly safe to use a little bit of this. I'm just going to spritz that on. Just like that. And now I'm going to get a toothbrush and just scrub that clean. And I'll dry it off. There we go. So as you can see, it doesn't look terribly pretty, but that is on, it's electrically sound, that is a fixed graphics card. And then as a final thing, we could put the connector back on. And that would be the job done. And that is your basic way of doing an SMD repair with a garbage soldering iron. So when people say, you have to buy a really expensive soldering iron, no you don't. It'll make it easier if you do. It will make your life easier, but you don't have to. So it can be done with cheap equipment, and that's how you do it basically. And that is a rough as guts but perfectly functional repair. Now, just for funsies, as a demonstration, I'll show you the correct way of doing it. So what we're going to do now, I'm going to take this back off and I'm going to put it on as if I were fixing it with my modest equipment, which is my TS100 basically. So let's remove this again. Now, removing an SMD component with a soldering iron is quite difficult to do. It can be done on the small stuff, like small components like this capacitor here, that kind of thing. You can just put a giant solder blob on there and just blob the whole thing away and melt it into oblivion. However, that's not really practical. If you want to take that off of the board now, realistically, you don't have a good chance of doing that with a soldering iron without doing some damage. The correct way to remove that is with a hot air gun. So now I'm going to get out my hot air station. So let's take this back off the board so I can demonstrate a cleaner repair. So I'm going to go in with the hot air. So for those of you who don't know, the hot air gun, this is spewing out a stream of air at 400 degrees C. So it's going to melt everything in its line of sight. So again, we're just going to apply the heat onto there. Wait, and as soon as that solder melts, I'll just be able to lift that right off with the tweezers. There we go. And off it comes. I'll put that to one side. And now I'm just going to swap out my soldering irons and we'll start cleaning all of this up and make it look nice and schmick. So just as a point of comparison, the crap soldering iron, that took about 10 minutes to get up to temperature or so, 5 or 10 minutes. It wasn't as painful as I thought. Bigger iron might have taken longer. But just as a comparison, this is a TS100 at 20, let me just turn that up a bit to 24 just to give it maximum power. This is a TS100 heating up, and it gives you an idea of how much quicker an iron like this is. So if I press the button to start heating, and watch that temperature soar. So 200, 300, 400. That is ready to use. And we'll just plug that in. As you can see, it's ready to go. So I'll just tin up that tip just to get it nice and shiny and ready to go. So as you can see, a decent soldering iron, and this isn't a super expensive one either, you can just see how just spending that amount alone will get you orders of magnitude above one of those garbage soldering irons. So while I say you don't need to buy an expensive Hacko and stuff like that, but getting something like a TS100, if you do any kind of soldering on any kind of regularity, really good idea. So I'm now going to use this solder wick just to remove all of the solder from this area so we can get down some nice, whoops, knocking the camera, so we can get down some nice clean stuff. So What the solder wick is, it's braid. It's just copper braid, and it absorbs, it soaks up excess solder like a sponge. And I'm going to combine that with some flux, which is also going to help the solder flow. So put a bit of flux on there, and now we're going to soak up all of this solder so we can start again with fresh stuff. And straight away, with the extra equipment, I'm just cutting through this solder like butter. Whereas the other one, I was having to hold it down to get heat into it. You were seeing how much trouble I was having with it. Whereas this one is just going straight in there and just burning through the solder. Just take all of that up until we're right down to just the tin pads. I put quite a lot of solder on to get that job done. So we've got quite a lot to take up here. I'm just trimming off the end and soaking up new stuff. And now I'll just run the iron over all those pads just to make them nice and ready. There we go. Clean the iron. Okay. And now what I'm going to do, now I could use the same technique where I just, well actually, I will use the same technique. So we'll just put just a dash of solder on these two pads. Oh yeah, I need to clean up the resistor as well. So let's just quickly give this guy a quick run over. Put some new burn holes in my mat. That'll do. Okay, and once again, I'm just going to nudge this into place. And because the solder pads are dead flat now, we'll actually be able to get this guy to go completely flat. So I'll press that down and heat. That's one side done. And now we need just a touch on the other side. And finally this time, and now finally I'm going to use the alcohol to clean up. So alcohol, toothbrush, there we go. And as you can see, while still visibly hand soldered, that is a much, much cleaner job. The solder blobs are smaller, the device is completely flat on the board, and there's just no excess solder there at all. So that's the effect of using good equipment and how much easier it is as well. You can see how just everything was easier when I was working on it. And that was with my modest mid-range tools. So that gives you an idea of the difference. So in summary, doing a fix on a graphics card with crap equipment is absolutely possible. And, you know, it's not about, I mean, practice will obviously help a lot. However, technique is far more important than practice. If you have the right technique, it will be easier. The reason why I made this video is when I was watching Jay work on it, and again, nothing doing to Jay, everyone's an expert of their own field, but I was watching him, he was pressing the soldering iron down on top of it like that, kind of just sort of hoping for the best, and I'm like, no, that's not going to work. You need to get the heat from the iron into the device. So you need to get a nice big side edge and get it right up against the solder that you're actually trying to melt. You can't rely on just holding that tip down on top and just hoping that it'll just laser the energy in there. So that's that. And that is the basics of doing SMD soldering work. I've demonstrated how to do it with amateur equipment and how to do it with the mid-range equipment like the stuff that I use every day. And again, if you had a super expensive soldering iron, that's going to make your life even easier as well. So you might ask yourself, well, if I had such an easy job, then why might you buy super expensive equipment over the mid-range stuff that I have? Well, the answer to that is if we take my hot air station, for example, it's this cheap old thing here. This is the equivalent of using the crap soldering iron. The heating element is in here, and it's got a fan there that blows the air through. When you use an expensive hot air station, I think the heating element is still in the end. I'm not 100% certain, but the fan, that is all in the actual unit itself. So you have a big old hose attached to it. And the effect that you get from that is that you get more airflow, a cleaner airflow with less turbulence in it, so it directs better, and less heat loss. Because I can set this thing to 400 degrees indicated, but the air coming out the end of it is probably nowhere near 400 degrees. And that's why I tend to run my soldering equipment, like this hot air station and my soldering irons, I tend to run them quite hot at 400 degrees. Theoretically, there's going to be a couple of people out there who are just like, solder actually melts at like 320. You don't need your iron to be that hot. I'm like, when you have crapper equipment, you do. When you've got really posh equipment, you can have the temperature lower, and that gives you more control as well. However, if you have lower end equipment like this, you can turn the temperature up and it will make it easier for you. But also just remember that when you start messing around with temperature, like I could turn this up to like 480 degrees. And you can say, oh, you've got more heat. That makes it easier, right? At 480 degrees, you're going to start destroying the motherboard. You'll get all of the actual pads and the copper traces will start lifting away from the board and damage like that. So, as I say, you do still need to be careful. However, I'm rambling now. There's a long and complicated discussion to be had over equipment and the pros and cons of it. But I hope that this video has just given you guys a crash course in what to do in a panic situation. So I hope that was kind of interesting. Thank you very much for watching, and congratulations to Jay. Good job doing that soldering job, because I know you had a lot of haters in your comments on that one. Don't listen to him, man. Well done for soldering it. See you all next time, everyone. Bye for now.